everybody, welcome back today. And today we're going to be talking about graphs. And graphs are a very common topic in computer science, and it's also thought to be a very hard topic because it can be applied in so many different ways. And it's also very important in algorithm questions. And actually, graphs are everywhere. Like, we've seen graphs every time we've been on Google, all kinds of websites, and we just don't realize it. So today I'm here to educate you on them, and I hope you enjoyed this video. But before we get on to this topic, please make sure to like this video, uh, subscribe to the channel, and let me know in the comment section below any video ideas that you have or any kind of topics that you want to see. But without further ado, let's get going.
Alright, so let's get started on graphs. So here I actually have a graph structure drawn out, and as you can see, if you've ever heard of in programming, if you heard of trees, it looks kind of like a tree. Usually a tree would be uh, top to down, so like something like this. You would see this kind of structure right here. This would look more like a tree, but in graphs we see that, I'm gonna change my color here, we see that we have multiple connections here, and it's more like a here I drew it horizontally, but it could also be vertically. But you see that there's multiple connections to one node, and nodes are connected between each other. Like here, we see that kind of here pattern here, and in some cases even sometimes they look like linked lists, right? And yeah, we can build up on top of this, and this is kind of a these are all built on top of the idea of linking. So you see how this node is connected through this. We call these edges here. So the ones I'm circling here are called edges, and these are nodes. The yellow ones I'm circling in yellow. But you see that these edges here connect these nodes. And let me move all that color, otherwise it's gonna look messy. Oops. Got rid of an edge there. So I'm going to redraw this node right here, but we see that these edges are connecting these nodes together. And in graphs, we can have directionality. So what that means is, I'm going to erase this tree here. And directionality means that these edges can have a specific direction. So this edge could be pointing this direction. They could all be pointing this direction. So in this case, we see that they're all pointing towards the right in this case. But in some cases you don't have directionality. In some cases you do. They could also be bidirectional, so it could also have an arrow pointing back. And this can all be done through code. And it can also be bidirectional like that, where the node points to the right of it and also points to the left of it. There are also these edges here. They can have weights. So weights basically are just like in real life. Weights make something more preferable, or in real life case, if you have a weight, it's harder to go somewhere, or it's harder to do something. Here, weights can be applied with the same concept, except sometimes we use something that has a higher weight. Like, we could assign a weight to this edge of 0.8, 0.1, 2.5, 0.6. We could say that we want something that has higher weights from this node, so we might go to 0.8 and we might go to this node. And so this kind of idea would actually be applicable in pathfinding, right? Or like in your Google Maps, when you're trying to find the shortest distance to a spot, right? Usually what they do is the cities are nodes, so these would be cities, the different random cities, and each of your edges are roads, and they assign weights, and then they try to pick the one that minimizes these weights, because that's the least distance, or the shortest path to get to whatever location you set. Same thing these graphs can also be applied to friend circles, so like Facebook or Instagram. You have your friend, right? And your friend has more friends, and then they might have a mutual friend, right? And then they have more friends, and then these are your friends could also be friends with your other friends. So this could be like something like this. So you see how this is like a friend network, right? So a lot of times networks and this kind of modeling is done through a graph right here. So this is very common actually. So like networks. And so key things are, you have nodes, you have edges, right? You can have directionality. You can have weights on these edges, right? Weights. I'm pretty sure I spelled directionality wrong, but whatever. We can have weights on these edges, and then we can have, and there are many applications. So there's networks, there's pathfinding, there's Google search. Google search is also built off of graphs because if you think about it, whenever you have a keyword, you're looking for all the type of content that goes to the keyword, and each of those contents also has subcontents, and it keeps going like that. Also build off of graphs. Um, yeah, and then also many graphs also have will combine like some graphs will actually look just like a tree, so they won't actually have connections, but those are still called graphs. It's just those are specialized graphs, just like how linked lists are specialized trees. They're just the worst condition of a tree. Same thing. A tree is like the worst condition of a graph, and so as you can see, that's kind of like directionality and having multiple nodes connecting off of a single node is very powerful, and it can be used for many things. Um, and then finally, these kind of graph questions, you'll see they'll ask for breadth first search, which is I'm going to denote as BFS, and then they'll ask for depth first search. And this is also applicable in trees, but in graphs, it's actually way more powerful. And in fact, this pathfinding is done through a breadth first search. And there's many algorithms like Dijkstra's algorithm, A-star algorithm. There are many kinds of algorithms that are built based off of graphs in order to do pathfinding. And in fact, in a future video, I'll show you guys actually how to code this A-star algorithm, and we'll like make a really nice. We can do a really nice UI for this, and if you guys want to see that, let me know in the comment section below. That will definitely be something I would be interested in doing. And so you guys see, as you see, graphs are super powerful.
All right, so I hope you learned a little bit about graphs and computer science, and let me know in the comment section below if you have any more questions or if you have any video ideas. And also, again, like I said in my last video, we're going to be having a lot more videos now, so any ideas are appreciated. But anyways, thanks for watching, and I hope to see you soon.